from this app I'm using. So today we'll continue the linear regression, and still we're using R. So I fixed the bug from yesterday, but I wanted to start afresh. So I'll show you a couple of things I did. Now, that file I gave to you, the one that says class, you have it in your documents. All right, that's good. So come to your this files window. We've not used this window since the beginning of this class. Let's use it today. Yes, don't worry. Create a new script. Just do Control Shift and create a new script. Okay. All right, that's fine. So come to files here. Are you there? Yeah. So by default, it will be in your root directory. So you see it should be in your documents. If you look at the files there, it should be the same files as the ones in your documents folder. These are the files in your documents folder. So now look for the one named class. That one should be inside this R folder. Okay. Then let's look for the folder class. This is it. All right. So open regression, simple linear regression. Open R. Then just wait. So I'll do the same on my end. Find the folder class, regression, simple linear regression, arrow. While I'm here, in your viewport, you see this cogwheel. Are you seeing this? The one that says more. Yes, click on it. Then scroll down to the end. You see an option that says set as working directory. Now just click on that. All right, so once you click on it, now you set this directory as your working directory. All right. So that problem we had yesterday when we are trying to call the data set that was not coming, this will fix it. So we'll continue. We'll just repeat the same thing. Simple linear regression. And step one is to import the data set. And just like yesterday, we'll say that data set will be equal to read.csv. And because the file we are calling is in this working directory, salary data.csv, we will just pass the name. And to show you that it is in the same working directory, once you say type SA or S, press tab on your keyboard, it should auto-complete it. That is confirming that it is in the same working directory. So here, equal to read.csv. Press enter. Yes, then quotes, double quotes, double or single. Just press S, uppercase S. The file size is uppercase S, then tab on your keyboard. Tab. So it completes it automatically. So you see that it's saying this is connected to this. So we don't have to do file.choose anymore. Once we do this, it connects automatically. So the issue with yesterday was we did not set the working directory and we are trying to do magic. That's why it was not seen. So, but today we set the working directory. So now our data set is, once we run this file, we'll have data set created as a data frame. And just like that, you have your data frame created. Confirm that yours is working fine, please. Okay. has brought it out. So that was the issue. That was what we were missing yesterday. We didn't set a working directory. Now, this data set has two columns, years of experience and salary, where we are trying to use the years of experience to predict a person's salary. And now you know that by convention, the X variable is years of experience and the Y variable is salary. All right, so let's get back to Adam. We've already imported cat tools, so you don't need to import cat tools again. All you need to do now is just to activate it. So we need to split the data set into the train and test set. And you know that to activate your tools, you can go to packages, search for cat tools, or you want to show yourself and just do library cat tools and it's activated. And from here, we can repeat the same processes we just did yesterday. Where we did set seed is 1, 2, 3. Is that Sophia? Yeah. What is she saying? Yes, activate library.cat tools. So we'll set the seed, and the seed is 1, 2, 3. Now let's split the data set into the train and the test portion, which is no different from what we've done yesterday. So we'll say that split is equal to sample.split. And the way it works in Arrow, okay, sample.split. Hold on. So we'll pass in the data set. So the name of our data set is data set. And we want to grab, first of all, what we want is to grab the Y feature. Excuse me. While we are splitting in Arrow, what we are doing is that we are splitting based on the Y feature. So X is the age, the years of experience, Y is salary. So when we say sample.split, we will do data set $sign salary. Then we no, we will not add the X. I'll show you how it will work. We will not add the X. We will only grab the feature we want to use as our Y variable. So we want salary. Then we'll define the split ratio. We'll define the split ratio to 2 divide 3. All right. So now we've done the split. So if you run this, we've done the split. So here you have your split. Are you done? Yeah. Okay, now you've done the split. So we want to now create the training set from the test set. So we'll create a variable, call it the training set, and that will be equal to subset from our data set, comma, split equal true. Remember, you can just do a uppercase T, and that stands for true, or you can do a uppercase F. All right, because inside the split, if we call the split variable here, oh, now if we call the split, this is what we get. Look at the result: true, false, true, false, true, false, true, false. Right? So the areas that are true are it has divided the data set into this portion, right? Into this portion. So yeah, so some parts now are true, some parts are false. So the training set will be where the split is equal to true. Then the test set will be where the split is equal to false. So let's see if we can count how many truths and how many false we have. Let's count the true values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. How many? 19. Then let's count the false. 1, 2, 3, 4. Is that 5? 4. Okay, 4, 5, 6, 7, 8, 9, 10. That's 10. All right. So it's what it has done. Now, when you do on your calculator, let me pull out my calculator. When you do 2 divide 3, you get 0.6, 0.6667. And let's just call that 70%. Right? So let's say 0.7, that's 70%. So the test portion is 70%. The train portion rather is 70%, which is greater. Then the test portion is the remaining 30%. And how many observations do we have? We have 27 observations. So 30, okay, we have 30 observations. So if you're calculating 70% of 30, that will be how many? Of 30, yes. That would be easy way to do it. 7%, 70% of 10 is 7. Okay. So that's 3 going 3 times. So that's as good as doing 7 times 3. That's 21. How many true did we have? 21. So you see that accurately, the training portion would be true and the test portion is the false. So in this first line here, where we just simply say split is equal to sample, and we are now using this seed. We use the random seed of 1, 2, 3 to pick the portions randomly. Now what we've done is we are sorting it randomly. So according to this, split is into 2. The 1 to 3 days. Yes, it's the seed number, like np.random.seed. Here, that's the same thing. This is the random, the way it's being sorted. This one is none of zero consequence, can be any value, but let's just use 1, 2, 3 in this situation. Next, now we are saying take this data set from this, according to this column which you are interested in, split the data set into this distribution 70% and 30%. Which one we want to use for our training yet, we have not defined. But all we know that this data set has been splitted into one part is 70, one part is 10, is 30. Cool. So when we are saying that the training set should be where the split is equal to true. So we are given the 70% for training. Then we will now say that the test set is equal to the subset where the data of the same data set where the split is equal to false. That now sets the training, the test portion to be the 30% because of what we've calculated here, where the training is, we initially just had 70%, 30%. Yeah. Yes, where it is true, goes to the 70%, where it is false, we set it to be the test set. That's what we are doing. That is making sense, I mean. That's why when you become the data scientist you want to become, you will charge well. Because you can see the learning part is not easy. So we'll create this variable, call it test. This will be the test set. And we'll simply change this to, remember, we can use F or false. So just for illustration, I will use F. Then I will execute both of them now. And you see, inside my global variables, I have training set and I have test set. So if you should visualize both of them, you will notice that this is the training set, right? Here, where I am looking at now is the training set. And you see we have 30. Why is it giving me 30? This is the test set. Okay, hold on, let me see. Okay, I was looking at the index number. It's not up to 30. So we're looking at 1, there's no 2, 3, there's no 4, 6, there's no 7, there's 7, there's no 8 and 9, there's 10, there's no 11, there's 12. So these are their index numbers. So this portion makes up my training. So what it does is, because we say based on this Y feature salary, it's picking the, remember that in the syntax here, we only specify the column of salary, yes. So by simply specifying salary, it will equally pick the matching rows for where, so it's doing a row-based operation. So it's still doing that for X. You understand? But it's giving preference that it's picking based on this feature because now it knows that this is the Y feature. So if we have multiple columns and we just pick the Y feature, it will do the same thing to select it row by row for the other features. That's what it's doing here. So right now we're just saying salary, but it's doing it for the whole data set. Now in Python, we would have had to say this is the X, this is the Y, which may be better because it's clearer to see that this is the X, this is the Y. But here you just specify it as your Y feature and it does that for you. So it just does everything. Now, what we are going to do is after creating the X and the Y, the training set and the test set, Arrow knows what is the Y feature already because we specify it here, and Arrow knows what are the X features. Just by doing this, saying that yes, it knows that salary now is the Y feature, and every other thing should be the X. It now knows that. All right. So after this, next thing is to fit the data with the model. So we'll create a variable, call it regressor, which is going to be our object, our regression model object, and that will be equals to LM. So if you do F1 on the LM, inside your help window, it shows you the documentation for this LM object, that this is the linear model. So this is how we create it. We say LM and you pass a formula. I'll show you how to create the formula. Then you pass your data and other arguments. So bottom line is just do LM for linear model. Then inside here, you say formula is equal to, that's your X variable, which is salary. And make sure you're spelling it correctly. So let me go back and say, okay, uppercase S. So that is salary. And remember this guy. And then you say, yes, experience. And please make sure you're spelling it correctly. And the data we are picking from would be equal to the training set. So what this formula is saying here, right here, what the formula is saying, excuse me, this simply means that we are defining a linear relationship between the salary column and the years of experience, because we are using linear model. So what we are saying is, hey, linear model guy, check the linear relationship between these two guys from this data set. So we are saying check if there is a linear relationship from this column of salary and years of experience from this training set data. So if we had said data was equal to data set, it will be passing the data from all of our data set at once without having the training and the data set. Yes. But since we have a training set, we are saying, hey, check if there is a linear relationship, which is what this squiggly sign means. Check if there's any linear relationship between these two guys according to this data set. That's what all of this is saying. So you highlight this regressor and run it. This is all there is. Yes, just run the regressor and it should be in your environment now. Okay, so this is it. Regressor. It's there now. Okay, what's this thing? Warning error in lm.fit x and y offset. Regressor formula equals the salary. Okay, your years of experience is this problem. This is uppercase Y. Is that what you use? Years experience. Okay, and that should be it. Let me see your regressor. This time. Okay. That was it. Sullivan. Yeah. Yeah. There's a folder inside here called class. Copy it to your documents, your documents folder. Copy to your documents folder. Just within that. Then Stalipi, we are almost done. Nope. For simple linear regression. All right, so you've created the model. Then let's do prediction. All right. So we'll create our y predict, just a variable name. That will be equal to predict, which is a function. So predict regressor, which is our model. And we'll say that new data will be equal to the test set. And that will be all. All right. Yes, run it. So if you look at our y pred, look at the y predict, these are the predictions. So these are the predictions. Now, look, let's take a minute and compare what we have. So this is what it's doing. It's taking the values from the, it's taking the x values from the. Mine is not okay. Because it's random. Mine is doing 2, 4, 5. This is row 2, row 4, row 5, row 8. No problem. No problem. We are picking random values. It's shuffling random. No problem. So this is what this is taking the x value from row 2 and making a prediction. So what I want to do now is I will go back to my test and compare. So right now the model is telling me that based on the years of experience from the row 2 that it picks the value from, this is what it is predicting the value to be for the salary, which I will compare now, and we'll also do the comparison on your own. So it took a value from row 4 and it took the x value and it made this prediction that this will be the expected salary. So I will see how true that test is. Now note that it says the based on row 2, 37766.7. And I'll go back to my test. Row 2. Hold on, let me compare something. Yes, hold on, I'll show you what to do. So this is my training set, right? There is row 1, there's no row 2. My test set, okay, this is row 2 here, right? This is row 2. It took the, this is row 2 here. It took this value of 1.3 as the person's estimated, as the person's years of experience rather, and it's predicted 37766 as the person's salary. And this is the salary in the data set. It's close, very close. Now, for row 4, it is telling me that this is the predicted salary. And also, it is much closer here. Row 5, it's quite higher because it's saying 46195. Although it's close, but it's predicting a higher value. And for 8, it's very close. So yes, I think I'm satisfied with the results. I think I'm well satisfied with the results. Compare yours and see if the values are close or they are far apart. Let me attend to Sullivan. So come to files. The folder I gave, where did you drop it? Yes. Okay. Yeah, this is this class. You open it. Regression, open it. Simple linear regression. Open here. Then you set this as your working directory. Now this is your working directory. So Arrow will be able to read the files inside of here. Then once you've gotten this, you can take what is on the screen. Yes, you don't need to. That was the issue we had yesterday, where we were trying to read the file directly and it wasn't coming. So with this, you see that in my case, I just specified the name of the file inside there. And I didn't have to say file.choose. Because I'm just, since I set that working directory, I'm just putting the name of the file. One cool thing is once you get the first letter and you put tab on your keyboard, it will autofill it. All right, so go ahead and take that one down. Fast. Salif, have you compared your predictions?
Yeah.
How close is it?
It's
Quite close.
So if I go back to and do the X predict, I mean,
No. We only need the Y predict.
sorry. So how do I get to compare the?
We'll build a chart for it. We'll do a visualization, yes, to compare the prediction against the actual, yes, against the raw data. While we are waiting for Sullivan, activate ggplot. All right. So now we'll battle that line from yesterday. Sullivan, how far have you gone? You're done with importing data set, right? Okay, so let's look at, okay, one more thing, Salipi, let's see something. Yeah, come on, also. So if I do summary, okay, so this is giving us the interquartile ranges, not what I want. Hold up, let me try again. Aha. Residuals call, this is, now this is where what I want you to take note of. These 3 stars, in arrow, when you look at this and you see these 3 stars, let me highlight them again. When you see these 3 stars, it means there is strong linear relationship. The highest is 3 stars. Remember that time when we said in the formula, check if there's linear relationship between this value and this value. This is the result of that. So 0 star means there is no correlationship. 1 star, very weak. 2 star, moderate. 3 star, high. So yes. So that's how we get these 3 stars. That's one important thing I need you to know. So you just by saying summary, then you pass your model name inside of the summary. It will print out the coefficient and show you how strong the relationship is. So you go from the range of 0 to 3 stars. That's the maximum you can get. It doesn't get better than that. All right, let's get with the building of the chart. So all I will say is yes, the regressor, this regressor you created. Remember the model name is regressor. Yes, so summary and regressor. Yes, control enter. Have you seen it? Aha. All right, so let's use our library ggplot, activate it. Good. So it is up and active. So the way we'll do it this time, I'll do ggplot, then I'll say plus. Sullivan, are you lost? Where are you? Test set, okay. So ggplot, then I'll do plus. Under it, I'll go on to say geometry will be points. And I want now I'll go ahead and set the aesthetics, where the X would be the training set, and I want from the training set the years of experience, and the Y would be equal to the same training set, but this time around it will be salary. So I know I'm having two, I don't need an extra one. So this will also be from training set salary. All right. Perhaps I need two of this after all. Then I'll take comma and I'll set a color. Remember the difference between mapping and setting. I'm just setting a color to be red. And the next set, I will take geom underscore line and we'll repeat the same process, set the aesthetics, and this time around, we are comparing so the X would be the training set, $, years of experience, and the Y would be the prediction. So it would be the prediction from the regressor. The new data would be equals to, so comma, new data would be equal to training set. Then I will break off and set the color to be equal to blue. Is anybody left behind? Felipe, where are you? Here. Where are you? Which line are you at?
I'm at the red. When I press enter,
Okay.
for it to come down, go straight down, straight down to the next line.
Yeah, it will go there. Use tab. Use tab to create the space you need. You've done the red, so just tab, then start again.
These things in your head. We get like
It's all about time, practice, time, practice. Besides, you're not expected to use all of them all the time, depending on the job. They just need you to have experience in, to know how to read and use all of these, like at an intermediate level. Did I close this? Color is blue. I will not close this part. Yes, there are, I think I didn't close it. Let me check. So two, then the comma is correct. Two brackets before the comma is correct. Then where is the last bracket? I don't know where I kept it, but let me just add it here. So this is 1, 2, 3, right? 3 opening. Then closing would be 1, 2, and 3. That should be as correct. And one more thing, after this, you need to put a plus here. After the red, you need a plus. Then end this one too with a plus, because now we want to set the title and the legends. So to do that, you just say GG title. And then salary versus experience. Then you say plus X label, which is years of experience. Then Y label, which will have salary. And this should be all for that. Let me run mine. And let me confirm if all is well. Remember, this was where we were having a drawback yesterday. Aha, and this is what we want to see. So the blue line is the regressor line, and it fits the data point. It catches the data point, the trend, very, very well. Where the red dots are the training data. Very fine. So what I want to do is I want to export this. And one more thing I need to show you that when you're exporting, always set your width and height. I don't think I've said that before. So your desktop screen is 1920 by 1080. And if I export this to if I don't set any what they call it, new location, Look at where it's going to. It's going to my working directory automatically because I've not set any location. But if I set this to save this particular image to desktop and save it, then I say save,
And all those ones will be saying that we said
they will be looking tiny. So now let me open up the one I just saved right now. This is how it's looking without scaling or anything. See how it's just looking. But the other ones that we didn't set all those things, they'll be tiny. You have to run the script again. So I can change this for instead of line, here is the plot. I can change this to smooth. Okay, so I can change this to smooth and run it. All right. Yeah, no difference in this case, but the line is just thicker. Yes, I think I like this one. So I'll export it again, save as image, set my dimension 1920, 1080, still save it to desktop. Just change the name, maybe plot 2, and save. That's all. Okay, I think I will break this. This is better, right? From the beginning. Who was with the flash? Give her the flash drive. There's a folder class. Copy it to your document folder. This is the new one. So these are the legends, right? Years of experience, salary. This is the plot title. So I'm just going to close it. And that's that for simple linear regression. It's as simple as this. Thank you. New script. Did you set once you create the scripts? Are you done with this? Okay. Once you create the new script, come to files, look for the folder class, look for regression, simple linear regression, arrow. Then set this as your working directory. Right. Then from there, you can just follow the class. No, start from the beginning. Start from here. Import the data set. from the beginning. Felipe, what's the issue with yours? Let me see. Are you sure it's not uppercase? Your caps lock is on.
I just on
Okay, this is it's uppercase.
if I save anything.
Let's see now. Okay, unexpected error, unexpected string in color red. So
So,
no, this is it. Color is not equal to red.
okay.
Okay, so now unexpected symbol in geom underscore line. Regressor, new data, and set color. So it's here. So there's no comma here. Okay, you are fine. If you're done, please don't forget to save this file properly. Don't forget to save it because in your files, you should save it to this working directory. Save the file to the simple linear regression folder. Where the data set is, just save it there. Yes, save it to your working directory. The same folder where you inside that class. Yes, remember you set this to be your working directory. So save it back there. And once you save it, you should see your arrow script opened inside here. Yes. Simple linear regression in arrow. I think what I would advise you to do is override the other one because that one of yesterday where we had plenty. No, it's exactly the same steps we followed. But yes, but I was having issue with this was where the issue was coming from. The plot wasn't plotting, and that was because of the method we used in building the model. That was really the error. What's this saying? Check, do you have this? This symbol. That is it. Say it again.
So after this, we are done with
Yes. By Monday, we should be starting MongoDB.
we are done with
Mm-hmm. Why are you people in a hurry to go? For Monday class, you need a lot of internet connection. So I pray that the network will be stable. Because MongoDB, they have it's usually online, like you need to be online for it.
because plus
I was not there when you registered. I don't know what they promised you. I was not there.
this should be just enter yeah Wi-Fi.
I've told you people to send mail. I've told you people.
It's for me.